I've been programming in Scala for about 3 years now, about 2.7. I saw Martin give a talk and was instantly thrilled. Before then, I was a Ruby programmer. Before then, I was actually a Java programmer. And seeing Scala, I was basically like, oh, I can actually use something which has the flexibility of Ruby with the power of Java behind it. And since then, it's lived up to all of my expectations and then some. When Alexei asked me if I was interested in doing a talk, there were a number of things that I could go into. And so I actually had an original talk planned, which was about writing play in practice and about doing some fun stuff with the authentication system so you could do remember me cookies and delve into the details of action composition. While it was fun to write, there's kind of a bigger problem, which is if you haven't used play, then it's not going to mean anything to you. If you have used play, then it's not going to be even new, and it's going to be really, really detailed. So I went back and I thought, OK, what's going to be fun? And what is going to be potentially risky, but is going to show you what you can do with play and what you can do in play that would be dubious, if not impossible, with other frameworks and with other languages. So this is going to be a broad talk. It's not going to be universal to all situations. I'm not attempting to say that this is the way, the light, and the truth. But there is one thing that play does do, and that it's a web application framework. It's awesome. And it's awesome not because it tries to do everything. Play is actually awesome because it doesn't try to do everything. Here's what play does do. It takes an HTTP request, and it returns or it streams a response. That's play core. That's literally all it does. The internals of it, we'll go into detail of it, but that's all it actually requires of you. Here's what play doesn't do, which if you can see that there's other frameworks out there, it doesn't tie an HTTP request to a thread. It doesn't tie an HTTP session into memory. It doesn't assume that you want convenient but unsafe practices. It's not going to try and make an entire website for you. It's not going to try and do any scaffolding, or at least not yet. It doesn't require that you actually have a particular object relational framework, or in fact, any relational framework, object relational framework at all. You are allowed to use ebean or anorm or slick or squirrel, but none of those are actually required. They're orthogonal to the underlying play core functionality. And it doesn't even mandate a particular template library. You can switch it out. And it doesn't mandate a particular routing format on top of that. So what it does instead is it provides you options out of the box. It provides you a build system. It provides you an HTTP API. It provides you with a template system out of the box, form handling, JSON support. And all of that stuff is available to you, but all of that stuff is loosely coupled and can be switched out as you need it, as it becomes inconvenient. So the build system, I'm just going to go through this really quick because, again, this is a broad talk. It's a modified SBT, and it allows you to create all of your projects from the simple library. There's a front controller that allows you to take in the GET or POST request that comes in from the server and allows you to route it. The router is awesome. The router actually allows you to take, either you can switch it out so you take UUIDs, or you can take things out your own classes and actually just plop them in as though they were parts of the actual string framework itself. The action, which is the base core of what play actually does, is that it wraps everything into a little bundle of functionality. And then you've got the immutable HTTP API itself. Everything in play allows you to go through cookies, through requests, through headers, and everything doesn't allow you to actually change the request itself. If you want to actually change anything in play and send it back, and it's part of the core API, and it's part of the core HTTP API, what you have to do is you have to create something based off of the original, and then you send that back in the request. So you never change the original cookie. What you do is, if you want to remove a cookie, you send a discarding cookie. And the same thing with the request, and the same thing with actions. You actually have to aggregate them together. And all of this is backed by Akka and is backed by Netty. And then you have the presentation on the front end. This is pretty much everything you'd expect. It has all the bells and whistles. And finally, you have JSON, which is very nice just because it provides you a simple data format that you can use to talk to JavaScript and use to talk back. And it allows you to query into that object and be able to change how those objects are written and read automatically through the use of combinators. It does just a ton of stuff. Basically, if you can think of it, then you can rely on having a problem. Then usually there's something in play that solves it for you. And usually in a way that's much more elegant than you were going to come up with at the time. So the big question is, all right, so that's useful, but why would you actually want to do that? Well, the answer is when you have to make a website, that's what they come to you with, is they say, okay, we need a product, go forth, make this happen. And then when you're actually coming back, you have to make two websites. You have to make a product website that all your users are going to see, and then you're going to be like, okay, I need something to actually administrate it and turn it on and turn it off and see whether everything's working or not. So now you've got two websites and they're both talking to the same system under the hood. Now you've got, a few years have gone by and you've got way more websites. You've got a product, you've got the admin stuff, you've got the customer service, you've got somebody doing business analytics and reporting on it, you've got somebody else doing business content and actually putting out the new version of the site and trying to put out a different version. And then you've got something that's managing long-running jobs queues or sending email on the back, and all of it is talking to the same domain. And this is something where Play is actually really useful because Play doesn't require you to do anything but send and send back. Okay. All right, how's that? Better. All right, excellent. Okay, so Play allows you to look at the same thing from different angles. And you're not going to touch the database because God knows that's awful enough and people have horror stories all over the place. And the answer is you can actually, with Play, you can actually break it up so that you're using loosely coupled stateless, composable services. What this means is that you can actually do the Play front end, and you can have it backed by Akka. You can create something that's completely back end and talks to Akka, and you can send messages through it, and you can remove all of the functionality from Play itself, which allows everything in Play to actually use messaging in the original object-oriented sense of the word. That is, when you're actually talking about objects, don't think about them actually calling each other and being mutable and changing state internally and all of that. Think about them being able to talk to one another. And the way that this happens is through something called command query responsibility segregation. And this is where it gets fun, because if you think about Play as something that's completely stateless, then the way that you actually change state is you're going to send a command to something else, and then you're going to get back one of two things. You're going to get back an event that says, yes, it worked, or you're going to get back a fault that says, no, this didn't work, something went wrong in the middle of it. All right, pause for questions. And there's also a prize attached to this, so there's an incentive here. Okay. So we've got a stateless Play application on the front end, and we create commands usually by doing a post. So you take the post and you wrap it, you turn it into a command, you send it into Akka, and then you get back an event. And that's all you care about from the Play side. And if you're querying for data, then you have this whole bunch of query services that send you back immutable objects saying, this is what the data looked like at the time that you asked, and you don't know anything more about it than that. And then you also have the option of broadcasting events. That is, when you send a post and you're processing a command, when that event comes back, that event can come back to everybody who's actually signed up to it. So if you're doing real-time web stuff where you're sending out chat stuff, or you're saying, I want to be notified when this guy logs in, whenever you're sending a command, the event can be streamed back to everybody who has an open browser and is listening for that particular user. So when you're processing a command, you can validate all input. This comes with its own nest of issues as well, in that you can actually be processing and displaying input that you really shouldn't be. So you have to be very careful about how you actually validate and pass that into the service so it doesn't try to get hacked. And that's what the API looks like. It's fairly simple. You have a command here, and you return a future, and that future is going to be an either that returns a fault if it's an error, or an event that's on the right, and it folds very naturally into Scala's paradigms, or idioms, I should say. So here's a diagram. Again, fairly simple. And you can see that as far as the domain service is concerned, we're actually sending a command in, we're getting an event back, we're calling out for queries, and we're getting back data. And again, play is completely stateless and just sitting in the middle of all of this. So here's what a command looks like. Again, a little more widely streamed. So this says you have a bundle of data. You package this bundle of data up, and it's just got a product, and that's all it is as a case class, which again, Scala makes really easy. You have an event, which again is a case class and has a couple of data bits added onto it. And you have a fault. That looks simple enough. This is all, assuming that you're logging in. So this is the session cookie wasn't there, or the session cookie didn't match up with what we thought it did. And then finally, we have queries. Queries are kind of different. Queries actually say we're calling out to something, and we're getting back data, and we don't necessarily know what's under the hood at all. We're not setting up a transaction. We're not necessarily calling out to what we think is cache. As far as we know, this is the data that we had at the time we had it, and it can be coming from a database. It can be coming from a cache. It can be coming from a NoSQL database like Cassandra or Riak. As far as we're concerned, that's our system of record when it comes to data. So there's a couple of things that come along with it, is that it's going to be immutable. It's going to return ranges or streams, because you don't want to ask for a million items if you can possibly help it. Because it's going to be something that's away from the ORM, you should avoid using something that's an HQL. And although you can put together your own query builder, it does get a little hairy to do. So avoid it until you really have to do that. And then we come to what Play actually does in terms of doing authentication and in terms of providing you with a context. When you log in, because Play is stateless, because Play doesn't have an idea that you went in from one to the next, it has to pull that in and know who you are every single time. So you do it from the cookie usually, or you do it from the underlying session ID that it comes in. And from this, you can create a wrapped request, and that request has a credentials object, which you can see back here, is that you can see that there's an implicit credentials that's being passed in for absolutely everything. And that's also actually being used in some of the commands, is that you can actually say, when we are calling for this, are we the person who we think has a right to be able to see this in the first place? And that's something that's very important to do, because again, you don't want to make this information available to anybody, and it is something which allows you to, it's an automatic marker on absolutely everything, that when you get a command, when you return back an event, you never lose track of who it is that's asking and in what context. Sorry, go ahead. Is that a lot better? Okay, that's a lot more echoey. Okay, so here we go. So we've got a request context. It's got all the state we need. We set up helpers on the templates to pass everything around, so everything that's using the template uses that context. And we end up with something like this on the actual page, where we are passing an implicit through. We are getting that data out. This is who you are. this is who the user is if we actually are hitting the user page. And you don't necessarily have to know what's going on underneath that. The helper will just pass through the context to everything that needs it. So this goes into more detail about streaming, is that, again, when you send an event, Play has something called an iteratee. And an iteratee basically says, when we get some data, deal with it. And, and it's funny because it really is that simple. On the other hand, it's so completely unintuitive that you can give yourself massive headaches trying to think about it too much. But once it has an iteratee, it takes that event and it uses something called a socket and hub internally to Play. Not very well documented at all. I recommend going out to the blog posts. And then Play sends it out through a server-side event or through WebSockets, as you choose, sends it to JSON. JSON picks it up and then handles the display of it. And the single best application I've found that actually demonstrates this is called Delilah, and it's by a guy called Ornikar Thras-Dupuis, I think. And I don't know exactly what sort of an inline he has to the guys at Xanixy, but he's been picking up on features in Play which were just like completely undocumented a good 6 months of anybody else. So if you can read through his source code, if you're ever stuck, that's an excellent way to know what to do about various strange things involving real-time web and broadcasting and all of that. There's also Vertex, which is, it tries to be a Java equivalent to Socket.io. And I don't know that much about it, except that they were working on making it be quite as usable as Socket.io, but hadn't quite managed it yet. And then finally, we have everything else according to Play. And I don't know where we are in time. 8:27, excellent. So, a couple of things. Avoid the Play logger if you can possibly help it. It's not hard-coded, and you can implement your own, and that way you don't have to go through it directly. Amongst other things, it has problems when you have configuration where it ignores what you're doing and decides to go on its own merry way. Metrics, it doesn't come with a metrics application included, but there's one on Coda Hale's website that you can use to track everything in more detail. And again, because you're using commands and events and doing queries, you can actually log all of those and pass those into the metrics as well and have much better fine-grained analysis. And then finally, testing, which is, again, if you're looking through something and you're getting a post request and you know that you're going to be sending a command, that makes it really easy to test. If you are getting back an event and you want to make sure that you're dealing with it, that makes it really easy to test. Queries, they're a little more hassle because the thing is that you have to swap out everything that's actually doing the querying underneath the hood, and that involves typically a dependency injection framework, which isn't all that fun. And finally, load testing is just the same old. As far as I know, there aren't any quick fixes for Play applications. I don't think that type-safe console is available to everybody, but I know that JConsole and JMeter will tell you just about everything you need to know if you ramp it up available and stick it to the JMX. All right, so that is the broad overview of CQRS and a Play application framework. And I'm seeing a lot of blank faces, so how much of that was actually fun? All right, question. What would you inject into MongoDB? What ABI? API. So there's a couple of Scala drivers that I know of for MongoDB. There's Salat and then there's Casbah.
Salat's built on top of Casbah.
Yeah, so Salat uses Scala sig internally to provide a better type safety onto MongoDB. But as far as I know, they both work. And I don't really have much of a preference. I did find that Salat was it was more useful in sort of allowing me to ignore the fact that I was using Mongo underneath the hood. If that helps, yeah. Okay, sorry. The question was, so this guy, Eric Evans, likes to talk about CQRS in the context of event sourcing. And event sourcing is a style of programming that's used in accounting a lot, where all of the transactions are gone through and you end up with a view of the model that you're looking at. So say you have a user and you change the name and you change, like his date of birth and everything else like that. All of those get written out as events. And then when you're actually looking at the user, it goes through all of those events and then creates that view from what was actually written in as events. And that can be extremely helpful when you're talking about financial transactions. If you're talking about something which is just bog standard user data, it's not necessarily all that much of a win, and it adds a lot of complexity onto your model. And that's why they're useful concepts in and of their own right, but they don't have to be conflated. So that's mostly why I left it out. It's like, yes, you can do it, but you don't have to do it. Okay. Okay, so about deploying Play. Play is, one of the things that Play doesn't do, unfortunately, is it doesn't allow you to package it as a WAR application. And so, sending it into a J2EE context just doesn't make any sense at all. Fortunately, what you can do is you can use, you can package it using Ansible, for example. Ansible. Okay, so yeah, if you Google for like Play2 and Ansible, then there are a number of people who are trying out different deployment tricks to actually push it out to Chef or push it through their deployment network and be able to deal with it on that basis instead of having to pass around raw zip file and write their own shell scripts. If Tomcat 6 and 7 are using a J2E framework, are you saying into Tomcat 6 and 7? Yeah. I don't think you can if they're using a J2E context, because it's actually backed by Netty, and Netty is its own completely asynchronous web server. So in that context, you'd use Tomcat in a situation where you wanted to offload that, and part of the win of Play is that it completely ignores the request model and just dumps it off the side. Okay. Wow. That is a really good question. Okay, so he's asked if the logging and metrics are actually done as particular events themselves. I believe that certainly there are frameworks available that send, if you use logback, for example, that sends out a log event, and you can definitely hook that into your own system however you like. If you're using CodaHail's metrics gem thing, I believe that also uses its own version of events, and I know that you can hook it up to a Graphite server and be able to see requests per second and all of this other stuff based on the metrics that come out of it, but I don't know the details of it, I'm afraid. Yes? That's a very good question, and currently you're in the lead. So Play, the routing API is very good for some things and not so good for other things, in that it's very good for letting you modify each part of it and then have everything be type safe after it. And then there are some other things, like if you're setting up a REST API, for example, the default routing API can kind of be a pain to set up. Because you want to set up different namespaces, you have all these common verbs, and you just have to do it manually, line after line after line. There is actually a library called Play Navigator. It's by this guy called Timon that actually is specifically set up for doing REST APIs. So that might be more to what you want. And again, if you want to write your own routing API, it gives you an idea of where to start. I can't hear that. In terms of efficiency? Wow. Yeah, I don't know whether writing something using a macro would make it any more efficient in terms of runtime. I don't know how much the routing actually costs on Play requests, for example. So it could be that it makes it 10,000 times more efficient, but it's still only 1% of the request. So. Okay, in the back? I don't know that anybody is actually focused on doing annotations, probably because, like, whenever people talk about annotations, they talk about it in a Java context. And from what I can tell, the trend seems to be towards using more implicit objects and doing auto-conversion inside of that scope, rather than because you get more of the type safety, whereas if you use an annotation, that's its own thing completely, and it doesn't really mix into the rest of the systems quite so well. Okay.
Well, thanks, Will.
Thank you.